So when we take a look at our continuing focus on weather maps, we're actually going to move into air masses. And so an air mass is going to be a large body of air that has pretty consistent temperature and humidity across the entire air mass. And so if I take a look at this continental polar, it's going to be cold and dry, but this air mass is going to be the same temperature and the same type of moisture in the air. It's going to be dry. Whereas if I come down here and I take a look at a continental tropical, it's going to be hot and dry because it's coming up from the south where the weather is going to be warmer, and then colder air is going to move down from the north. Okay, so when we take a look at how these different air masses originate, so overland, so I have a continental Arctic, a continental polar, a continental tropical, those are going to originate overland, continent, land. Okay, then it's going to originate over water, it's going to be maritime. So a maritime I can have if it's coming from, again, the north where it typically stays colder temperatures, it's going to be a polar, or if it's coming down from the south, it's going to be a tropical. So it's going to be warm and moist if it's a tropical. It's going to be cool and moist if it's a polar, a maritime polar. Okay, so when we talk about cold air masses, you'll notice in the visual, cold air masses typically come down from the north. They can move in from the northwest. So sometimes we get air masses that move in from the northwest, or they come straight from the west. Whereas warm air masses tend to come from the south. So you'll notice that my continental tropical is going to come up from the south, or it's going to come from the southeast, or it's going to come straight from the east. There is some exceptions to warm masses. It's tend to, which means it doesn't always. We have something that's called an Albuquerque low. That's a weather system. So it's a low weather system that forms over Albuquerque and it moves north. And typically, when we have an Albuquerque low and it moves north, we end up with a lot of snow. That's an exemption of cold air masses moving from the north because Albuquerque is south of our location. Okay. So with these warm air masses, they have what are called fronts, and those fronts are going to intersect with other air masses. So when we have cooler air masses, those are going to be your high pressures. They're going to be more dense and flow towards area that's less dense. Remember, we talked about that wind goes from high pressure areas to low pressure areas. So as I have a high pressure air mass, it's going to want to go to where there's less pressure. And those less pressure, less dense, warm, and moist air masses are going to be low pressure areas because they're going to be that warmer air. Okay. So, again, how air pressure works, high pressure, they like to go the high pressure, the wind wants to go to low pressure. It wants to go to where there is less of those air molecules. Okay, so high pressure areas move into low pressure areas. Again, moving in from where it's more dense to less dense. So there's four types of fronts that we're going to take a look at. Okay, so you have the boundary between two air masses, that's the front. You have a cold front, a warm front, a stationary front, or an occluded front. And so these fronts are going to be classified by which type of air mass is replacing the other. So if I have a cold front moving in, that means I have cold air replacing warm air. If I have warm front moving in, I have warm air replacing cold air. Stationary is where those two fronts collide. And then we'll talk about the occluded mass as well. Okay, so map symbols are going to point in the direction in which the front is moving. So a stationary front's not moving, which is why you have the symbols going both ways. An occluded front, you'll notice that I have warm and cold together pointing in that direction. Okay, so when we take a look at a cold front is replacing that warm mass of air. So here's my cold front that's moving in. You'll notice that as it's moving in, behind the front, it's going to be colder and drier. The pressure is going to increase. Okay, so the moist air is pushed up over the cold air. So here is the cold front moving in. The moist air is pushed up. That's what this arrow is showing. It's going up into the clouds. And then this is where we get our showers and thunderstorms. Okay, so that when we have thunderstorms in the afternoon in the summers, that's because we have a cold front moving in to replace that warm front of the day. So with a cold front, the pressure is going to increase. The moist air is pushed up over the cold air, and then we end up typically with showers and thunderstorms. With a warm front, so a warm front, the warm air mass is going to replace the cold air mass. So the warm air mass is replacing the cold air mass. The air behind the front is warm and moist because it's a warm front. So I have warm and moist air. And because of that, my pressure is going to go down. Okay, so because the pressure goes down, I have a gradual rise. You'll notice that this arrow is not nearly as steep as it was with the cold front. It's gradual rise of warm air over cold air. So the warm air is gradually going to rise over the cold air. And typically, when this happens, we end up with lots of rain moving ahead, rain or snow moving ahead along this front. Okay. A stationary front, so if you take a look at the graphic here, a stationary front is where the two different air masses, neither one is strong enough to replace the other. So the air masses don't move. So I have both a cold front and a warm front happening, or I have a cold mass and a warm air mass. And so along that front line, neither one is strong enough to push the air up and over. So we end up with light rain over an extended period of time. That's what you'll see with a stationary front. Then you have an occluded front. Okay, so an occluded front is where two cold air masses converge on a warm air mass. So I have two, so if we take a look here at Indianapolis, this is where we're going to look at. I have two cold air fronts. I have one coming in from St. Louis. I have one coming in from Columbus, and I had a warm air front over Indianapolis. And so what happens, the fast moving air front comes over and overtakes the warm front, pushing it up and over cold air. So this warm front or this cold air front from St. Louis came in very fast. It pushed the warm air up over the other cold air front over here. And so as a result, we end up with some thunderstorms that result along that front. Okay, once that front goes by, it typically becomes clear and dry at that point. We have a backdoor cold front. So it approaches from the east and the northeast. And a backdoor cold front is when Atlantic maritime air is moving in from the east and replaces warmer, drier continental air. So you'll take a look here in Florida. This will be common here because I am having air coming in from the east and northeast. It comes in, it provides cooler weather. You'll notice that here's my front boundary line as the cold front moves in, and it's replacing that cooler, or it's making the air cooler than the warmer air that was on land. There are different weather instruments that we use to track weather. And so we have a barometer. So a barometer, which is what we looked at in the Explorer, it measures atmospheric pressure in both millibars and inches of mercury. And so this is what it looks like. So you guys saw this where we have a barometer of very dry conditions, fair conditions. The weather is changing, rain, and then it is really storming. And then we have the millibars are on the inside as well. Then you have an anemometer. So an anemometer measures wind speed. And so as the wind picks up, it spins this around really, really fast. The revolutions are counted, and then we get the wind speed. And then you're all very familiar with what a thermometer does. It's measuring the temperature in both Celsius and Fahrenheit. So those are three types of weather instruments that we use to track weather. The barometer is tracking pressure, the anemometer is tracking wind speed, and then the thermometer is tracking temperature. Okay, so continuing with weather instruments, we have a weather balloon. So a weather balloon is going to carry instruments to high altitudes to measure the pressure, temperature, humidity, and wind speed. A compass rose is going to determine wind direction when reading weather maps. And then you have a wind vane, which will move the direction as the wind is going, so north, south, east, or west. All right, so hopefully after watching this video and the video on air pressure, you are able to use a weather map showing high and low pressure fronts to explain how global air movement affects weather. Um, and then we are going to be doing some practice with weather maps.